just want you guys to log in so I can see that you guys are there. Just stay on the meets. Just mute yourself or whatever. I'll probably be doing stuff on the computer. And once you guys finish, the 30 minutes are up, then I'll start the lesson for, I believe it's 1.5. Okay. So, like I said yesterday, you guys probably heard, the trig identities unit is empty right now. The other stuff, units 7 and 8, I have to add. But the trig identities one is empty right now because Mr. Murati and Mr. Summercamp did not get a chance to hit trig identities the first quadmester. So, based on how Mrs. Wisenden and I do the first few weeks of this, depending on how much we get done, you may or may not have to suffer through trig identities. Okay, so there's hope.
Is it that bad or like?
No, it's not bad. You guys get a formula sheet. It's just tedious. It's just tedious algebraic subbing and stuff and identifying what a trinomial trig identity is, and there's factoring trig identities, so that's pretty weird. But yeah, it's not the hardest thing. It's basically a puzzle that you have to solve. All right. So we're going to start with our parent functions. Okay. Hopefully this works. It works. Okay. So we have our parent function f of x is equal to x. What would my I guess x and y intercept be for that one? The origin, okay? And you're literally just going up by 1, okay? So what would our domain be for this?
XCR.
Yeah, XCR. And our range? YR. Okay, so pretty simple. Cohort C and A, if you guys have any questions, just feel free to type them out, okay? And obviously, f of x is equal to x is a linear function, okay? So like I did yesterday, we'll probably do one lesson before the break. And then I'll give you guys like 20 minutes to do the homework. And then after the break, we'll do the last lesson for unit for 1.4. So for B, we have f of x is equal to x squared. Okay. What type of graph is this? You guys remember? The quadratic, so it's a parabola. What's my domain for a parabola? XCR. And what is my range in this case?
Oh, y.
Yusuf?
Y is greater than 0 or equal.
Yep, greater than or equal to 0. All right. So as you can see, it's pretty easy so far. Okay. But then we start getting into, I don't know if they are the harder functions, but they're obviously involve more things, okay? So what would the next one be? F of x is equal to 1 over x. What do we call that function? Yeah, there's an asymptote at where? The zeros, right? So this is called the reciprocal function. Okay, and how does this graph generally look like?
Just doesn't touch 0.
Yep. So quadrant 1 doesn't touch 0, and then quadrant 3 doesn't touch 0. Okay. So what will my domain be for this?
XCR, x cannot equal 0.
Yep. Would the range be the same thing?
Yes.
Okay. All right. So far so good. It's basically stuff we did yesterday. Okay. The next one is what?
Absolute value.
The absolute value. So you basically have a V shape. Okay? So this is called the absolute value.
Wait, sir, quick question.
Yeah.
So for the absolute value, saying it can never be in the, like,
It can be in the negative axis as long as there is a reflection in the x-axis.
okay,
So if there's a negative in front of the x over here,
yeah,
then it can go down to the negatives.
all right,
Okay. What is our domain for the absolute value?
thank you.
Okay, and our range YER such that what?
Y is greater than 0. Or greater than or equal to.
All right. And then we're not going to do the domain and range for these ones. Okay, so we have the square root function. It goes like that. And what would the next function be called?
Exponential.
Exponential. Okay, so where's the asymptote for an exponential function?
Wait, what's the question?
Where's the asymptote for the exponential function? Yeah, so the x-axis is its asymptote because can that function ever be a negative number? As it stands right now. F of x is equal to 2x. No. So it's going to hit close and close to 0, but it's never actually going to hit it. All right. And the last one we have is our trig function, so our sinusoidal function, which is the sine graph. So sine graph starts at 0. Where's the next point? Let's see if you guys remember.
Isn't it like this or something?
Yeah, but it's 90 and 1, okay?
Yeah.
And then 180 and 0, 270, and then it goes back.
We have to know this? The quiz?
I mean, you guys should know this. Didn't you guys spend like a couple weeks on trig? And
Yeah, like, that was like
Our
first
couple.
semester, I don't remember any of this.
well,
Yeah, that
luckily,
is very useful.
luckily for you, you don't have to worry about this until unit 4.
Okay.
So just worry about the basic stuff until unit 4. Don't worry about it now, okay? So yeah, our sine function has an unlimited amount of x-intercepts or roots, okay? And its domain and its range is bound by whatever the amplitude is, all right?
So do we need to know the domain and range for the last two?
I'm pretty sure you guys can probably figure it out on your own. What would the domain be for E?
XCR,
Such that,
it has to be greater than or equal to 0.
okay? And what would the range be? Would be the same thing, right?
Yeah,
So domain and range are the same. Okay, and let's just do F, just because we're on the second last one. So what would the domain be for the exponential? XCR? Yep. And what would our range be?
Like y here such that y must be, well, y cannot equal 0.
Yep.
So it's greater than or equal
All right. And
So like for that one, I would just say that it can't equal 0. Like, can it be negative?
oh, right, you're right. So what should it be then?
Like, comma, y.
Greater than. Okay,
Oh, yeah, right.
because
Okay, I wrote that.
you can't hit 0.
I wrote that by accident.
So our range is y has to be greater than 0 because this graph cannot be in the negative y-axis, okay? And for sine, obviously the domain is x's and elements of all real numbers, okay? However, what would our range be for the sine graph? So it's y-e-r, so it's that what? So what's the highest point in a regular sine graph? The highest y value?
9 and 0 and 9.
1? Okay, max is 1. And what is the minimum value of y? Negative 1. So what would my range be bound by?
Always do like that.
Where the y is in the middle?
The y is greater than or equal to negative 1,
Mhm.
but less than or equal to 1.
Yep, perfect. So that would be your domain and ranges for E, F, and G, okay? So are you guys good with this so far? Okay. So, did you guys explore like what is an odd function, what's an even function in grade 11? No? Okay. So what even and odd has to do is with the symmetry of the graph. So if it's even, it splits right down the middle. If it's odd, it doesn't do that. Okay. So these graphs up that we did are the parent functions. Okay. Now we're going to look at even and odd functions. So an odd function is any function that has a rotational symmetry about the origin. Algebraically, all odd functions have the property. So f of negative x is equal to negative f of x. Okay. So I'll explain that shortly. You're basically just subbing in negative x into the original equation. Okay, I'll show an example. But if we were to just take this as is, what transformation does f of negative x have? Where is it reflected into? Y or x?
X.
No, x, the negative would have to be outside of the bracket. So then y. So this one's reflected in the y-axis. And how about the next one? That one's reflected in x. All right. So an even function is any function that is symmetric about the y-axis algebraically. All even functions have the property f of negative x. So again, we are reflected in the y-axis. Is equal to f of x, which is just the parent function with no transformations, okay? So I'll show you guys an example right now of what it means to prove. So let's take the function f of x is equal to x squared, okay? So we want to prove that it's even, all right? So we need to prove this definition, okay? So we have f of negative x is equal to f of x. We know f of x is just x squared, right? So what we're going to do is we're going to put a negative in the bracket where x squared is, okay? So we'll have negative x squared is equal to f of x. And any number, even if it's negative, if it's squared, what does it give us back? Positive. So you're going to get back x squared is equal to f of x. And we know that f of x is x squared, right? So we have x squared is equal to x squared, which means that this graph has is what, even or odd? Even.
So wait, sir, you said use like a number, right?
Mhm.
Prove it.
Yeah, so let's just take any number. So if we take negative 2 squared, what is that going to give us? 4, right? So regardless of if you have a negative x or a positive x, the symmetry is still going to be even because it gives you back the same y value.
So that's how we prove it, we just put
Yeah.
any random number.
Or like I did, I would just put the function in it.
Do we prefer that one or this?
Oh, I just put the function back. So we have x squared, right? But because we needed to prove f of negative x is equal to this, that's why I made the x negative, because of this over here, okay? But if we were to prove that it's an odd, it wouldn't work. Okay, so we'll take the same function. So let's take f of x is equal to x squared, okay? So we already proved that f of negative x is x squared, right? Because we did the work over here, right? So now to prove that it's odd, we need to show that this f of negative x is equal to the negative f of x. So the whole function negative, okay? So, so we know our original function is f of x, right? So we have is equal to negative x squared, okay? Because the negative is outside, okay? What, even though the number is positive on the inside, what does it bring us back anyways? Negative. So does x squared equal negative x squared? No, right? So the left side, basically left side doesn't equal right side. That's all you're proving with odd and even functions. You're trying to prove if the left side is equal to the right side. So therefore, not odd. And we have a couple more examples on the next page. So don't worry, we'll get through those so that you guys understand it better.
Like, it's not the same.
Mhm.
So when we do like that, process, it's true that it's not odd.
Yeah. So you can start like just by looking. If you have a function with a odd degree, you obviously want to try to prove that it's an odd function, right? Just because of the odd degree. Okay. So you would start with the odd function. Okay. And if you prove that it's an odd function, you don't have to do the even function. Okay. You can't have both.
So like when it's like not the same, that's when it's like even.
So it's either or. So for this one, we prove that it's even. Okay. We didn't have to prove that it's odd, but I just wanted to show you guys that it wasn't odd. So if at the beginning of the question you guys prove that it's even, just leave it at that. Okay. If it doesn't work out, then you have to do the next one.
Oh, so like the odd is like the second step?
Yeah. So just look at the degree of the function. If it's odd, I would say start proving the odd property. If it's an even degree, start by proving the even function property. Okay.
So
Yes.
odd is just left, left side doesn't, right now. What you just did was you proved it was an even function, but you also proved that it wasn't an odd function,
Yeah.
which is why left side didn't equal right
Yes.
side. Okay.
So with these, you're just proving left side is equal to right side, or left doesn't equal the right side. But if you try, let's just say you do an odd function and it says not odd, you have to prove that it's even or not even. Okay. So if I would have started with proving the odd and it wasn't odd, then I would have had to do this regardless. Okay. But if on the first try you get that it's an odd function, you don't have to prove the other one. Okay. So a function can either be odd, even, or neither. And neither is when none of these hold true. Okay. So for some questions you might have to be doing both. For some questions you might just be doing one of those. Okay. For the neither questions, you're 100% going to be trying to prove both are not true. Okay. And there's an example on the next page where we will get to that. Yeah.
I just don't understand like why are we doing like this?
Oh, so we're trying to prove the function's symmetry.
Yeah.
Okay. So if it's an even function, that means it's symmetrical about the y-axis. Okay, so you can, let's just take this. You can draw a line down the middle and it will be split identically in half, okay? An odd function is any function that has a rotational symmetry about the origin. So if you're rotating it a certain amount, it'll be considered an odd function, okay? So I believe, I want to say the square root function is an odd function. Yeah, the square root function would be an odd function because you're rotating basically, let's just say x squared over to the other side, okay? So we'll do some examples of that later. Okay, there's still some properties I have to teach you guys, but just know for these, you're just proving left side is equal to right side, okay? All right, so now we're going to move on to continuous and discontinuous functions. You guys, so remember a continuous function is any function that does not contain any holes or breaks over its entire domain. So what are some examples of a continuous function? A parabola. Because it continues upwards or downwards. What else?
A linear function.
Linear function. That's the easiest one. What's another one?
Absolute value.
Yep. All right. Anything else?
The one that goes like this.
Square root.
Yeah.
Over its entire domain. Yep. And the one you hated the most.
The sinusoidal.
Yeah, that's continuous. All right. So these don't have any holes or breaks in its domain. Okay. So a discontinuous function, so basically has any holes or breaks or an asymptote. Okay. What would be an example of a discontinuous function?
An exponential.
Exponential. Yep, because there's an asymptote. Okay. What's that function you guys learned? Did you guys learn about piecewise functions? No?
Sorry, what?
Piecewise functions. So it's basically a function where you have set rules and you have like a break in the graph.
Yeah.
So you'll probably have something that looks like this. And then it continues down.
Yeah.
You continue down there.
What is that called?
Piecewise.
Okay.
It's probably one of the, I don't know why they even made it a graph. No clue, but it's a graph.
Wait, sir, why is the asymptote one a discontinuous thing? It's not like it's breaking anyway. I mean,
It just doesn't touch zero.
Yeah.
Or
And
in this
the
case,
definition states that there has to be an asymptote or a break in the graph. Okay?
okay.
So is there an example of another discontinuous function that you guys can think of? Pardon?
Regular ask.
Okay. The reciprocal.
yes.
Break.
Yeah, but yeah, right? Because it has two asymptotes, a horizontal and a vertical.
So those are some examples of a discontinuous function. Okay. So when we generally read graphs, how do we read them? From right to left or from left to right? Left to right. Okay. So we have something called the interval of increase. So let's just take a simple parabola. What side of the graph would have our interval of increase? The right or the left side? Remember, you're reading it from left to right. So from left, you're coming down, and then when you go past the origin, you go right, and it goes up. So the right side would be your interval of increase.
Wait, I'm confused. What is that? Like, it says that where the y values of the function get larger, but like,
Yeah.
if it's
So-
like a parabola or something, like, don't they both sides get
But
larger?
because you read it from left to right, from the left side, you're coming from the left side of the x, right? So when you come from the left side of the x, the values of y are getting what? Smaller, right?
Okay, so it goes like this.
Yeah, and once you pass the origin, you can start getting to the right side of the graph where the y values start getting bigger.
Okay.
Like not like still like that's so cool. That's like the interval of increase. It's like
Pardon?
like if like what if it's like going down or something?
Mhm.
Is that still like the interval of increase?
If it's opening downwards.
Yeah.
So if we have this, is what you're saying?
Yeah.
So from left to right, so from the left side up to the vertex, it is increasing in y values.
Okay, it doesn't matter like what side it is, as long as it's like left, right?
That's right. Just read it left to right. So in the downwards parabola, the interval of increase would be your left side up until the vertex.
Okay.
Okay? So if we were to write this in set notation like we learned yesterday, how would we write the interval of increase in set notation?
What's that again?
Do you have the open brackets or the square brackets?
Oh, okay. Maybe both closed circles, or like one closed and then one open.
Which one would be closed?
The one at the very first one.
So 0?
Yeah.
Okay. And why would the next one be an open bracket?
Wait, like we're talking about like the
Interval of increase.
yeah, because like then it has to continue on the other side.
Yeah, so the interval of increase starts at 0 and goes all the way to what? Because the parabola is continuous,
Infinity.
infinity, because we don't know, there's no definite value of where it stops.
So this always changes, right?
Yeah.
What the thing-
So it depends on the graph. So if this didn't have any arrows, okay, and it just had a closed dot at that point, your interval of increase would be square bracket 0 to wherever that number is. And then it would be another square bracket, okay?
Okay.
So let's just say I had the graph end here. Let's just say this is 3 and this is 1, okay? What would my interval of increase be?
Oh wait, like you want the
In set notation.
close, close bracket, 1 and then 3 and then open close bracket.
So because you have that arrow, you always assume it's going to infinity.
But what about like the asymptotes? Like how do we do that for the asymptote?
So that is so for this one, okay? So if you're reading it from left to right, okay? The interval of decrease is from open bracket what?
That's what
Yeah, so the asymptote is at 0, right? Correct? It doesn't touch 0. So the interval of decrease or increase for this, there would be none. Because from left to right, it's decreasing. If you continue from left to right, it's also decreasing.
So we wouldn't have an interval.
Of increase in that and the 1 over x, no.
Wait, there's no interval of increase.
There is. And then I would explain that. So that's the next one we're going to do, okay? Yes.
So the interval of increase, like the x-axis or like y-axis?
You're looking at the y values.
Yeah, okay.
So here we have the intervals of decrease. Okay, that's where functions with the functions domain where the y values of the function get smaller. Okay, moving from left to right. So we're going to take the example of 1 over x. All right. So because we're moving from basically left to right, and there's always a decreasing value, okay? So what would the interval of decrease be for f of x? Or f of x equal to 1 over x?
Infinity.
Okay, so we're going to do interval of decrease. So if we're doing it from left to right, let's start with the bottom part. okay? So the interval of decrease is from 0 open bracket because it doesn't touch 0, but it gets very close to 0.
So then why do we see 0 for the first?
Pardon? Because the definition of the open bracket is that that number gets close to it, but it's not actually included in the graph itself.
Okay.
So it can be 0.00001, but it's not a definite 0, okay? Even if you round, whatever, it's still not 0.
But the open bracket also signifies that it doesn't touch that number at all.
Yeah, it doesn't touch it at all, okay? So the interval of decrease we have from 0 to what? Okay, and the interval of decrease, and there's another one, and where would that be from? So you would have it from 0 to positive and negative infinity because you're going from both sides to that.
Oh, you wouldn't do it by number one? Because wouldn't it be like from positive infinity to 0?
So the intervals, also, not bad. So we're looking at the functions domain when it comes to interval of decrease, okay? So, like she said, I said it was the range, but it's actually the domain, okay? So we're looking at the domain at the x values where the interval decreases from, okay? So the interval decreases from negative infinity to 0, and then from 0 to positive infinity, okay? So I'll write that down, I'll explain it again. So we're going to be looking at the domain, okay, not the range. Okay, so what I said for the previous example was technically incorrect, okay? So because we're looking at the domain, from what x values does this graph decrease from?
0 to. Oh wait, are we looking at the left side first?
Yeah, let's look at the left side first.
So wouldn't it be negative?
And what else?
And then it would be 0 to positive infinity?
Yep. So that would make more sense, okay?
Wait, so also in the interval of decrease, it's also the
The x values, yeah.
okay, that makes.
So obviously with the parabola, what I said was still correct. It went from 0 to positive infinity. Okay, that's where the interval of increase is. Which ones?
The intervals of decrease, like where they are, like on the graph.
Oh, on the graph. So the interval of decrease on the graph for 1 over x is over here because you're decreasing in x values. I mean in y values as the x's get closer to 0. And you also have one in quadrant 1, okay? From starting from 0, it starts getting smaller. Yeah. Yeah, you look at the whole thing. And if you were to, you guys are going to learn this notation too. So that's the union sign, okay, which means that
Together.
the interval of decrease holds together for both of those sets. Okay.
What?
So is that just another way of saying and?
Yeah, it's another way of saying and.
Oh,
It's just the U.
Okay.
does it matter like which one you
It's
use?
the union, what it's called. I don't care if you use and or the union. I just think the union one looks cooler.
Okay.
So are we just using set notation to describe the, to just describe the interval of decrease and increase?
Or yeah, you can use the other one, but this one is more, I guess,
Right.
helpful because it's just easier to do. Okay.
Sure.
So yes.
So is that like how like on a test or something, if they get that question, like, do we have to also write the int and then down arrow and then like?
Well, I just did the down arrow because I didn't want to write decrease. As you know.
Yeah, I know, but like, so like, is this the proper form, just putting them in the coordinates and that's?
Yeah.
it? Okay.
That's all I'm looking for. The interval of increase is correct because it goes from 0 to positive infinity, so that holds true for the parabola.
You look at it, it's starts at 0.
What do you mean?
Because you said it's always equal to x raised to k. It's good to do it.
Okay, so like I said, the one for the parabola, the interval of increase is from 0 to infinity, because from x is equal to 0 all the way until infinity, the y values get larger. Okay, so that one's true. Okay, in this case, with the 1 over x, from negative infinity going towards 0, okay, the y values are decreasing. Okay, so negative infinity is all the way. Negative infinity is all the way down here, okay? And this is 0, okay? So from negative infinity all the way to 0, the y values keep decreasing, okay? As you can see from this downward trend, right? And for the right side, from 0, so when we start from here to positive infinity, it decreases as well, okay? So that's why the interval decrease for this graph is both negative infinity and 0, and 0 to positive infinity. You guys confused?
Makes sense.
You guys want me to do a example with another graph?
I'm just confused, like,
Okay.
Yeah.
how would this work for the square root?
You just look at how.
For the square
Yeah,
root?
I know. Like you read it.
Okay, so
Just look at how it's
let's do an example with square root. Okay, so let's just do an example. Let's just say f of x is equal to square root x, right? So this is just the parent function, and it keeps going that way. Okay. If we read the graph from left to right, do we have a interval of increase, decrease, or both? Increase. Okay, and what is our interval of increase?
Like close bracket 0,
Mhm.
positive infinity.
Yep.
Open bracket, yeah.
Then I'm going to try to think of one that has a negative.
Or if it was just reflected.
Reflected?
Yeah.
That's true. So let's just take the reflection into the y-axis, right? So I'm going to erase this.
Yeah.
Is it not?
Why not?
Wouldn't it be like this?
No, that would be yes. If it was y, it's y, it would go this way.
It's gonna flip it like that way.
Yeah.
Not over
Because it's, so if it's like this, okay, this is the y-axis, like what's on the y-axis would be this.
Oh, that makes sense.
So reflected in the y-axis, we just have, it's basically the same graph, just going the other way. Okay? So do we have an interval of increase or decrease? Decrease.
Oh, decrease.
Okay, and what would my interval of decrease be?
Open bracket, negative infinity,
Mhm.
0, close bracket.
And then, so the end behavior is just us describing what happened, like in words?
Yep. So I'm going to get to the end behavior soon. Okay?
I'm gonna forget, I'm just gonna be right there.
So the end behaviors are descriptions of the values f of x. So as x approaches positive infinity or as x approaches negative infinity, okay? X approaches positive infinity is read as I just said it, okay? In other words, the end behaviors of a function describe what happens to the y values of the function as it becomes very large or very small, okay? So we have 1 over x again, So we want to look at the end behaviors, okay? So as x approaches positive infinity, so as x keeps going to the right, y approaches what value? So as x keeps going this way to the right, what does the y approach?
Was it to 0?
Yeah, because the asymptote is at 0. Okay? Because it keeps getting closer and closer to the x-axis, but it never actually touches 0. Okay, so that's why as x approaches positive infinity, y approaches 0. Okay?
Oh, okay.
You're just looking at the graph. This is all this is. You're just looking at the graph. Okay?
I think we're overthinking it.
So as x approaches negative infinity, so as x keeps going this way, what does y approach? 0. Right? Because it gets close and close to the x-axis, but it doesn't actually hit 0. So infinity is positive or negative if infinity is positive when it's on the right side of the graph, and negative infinity is on the left side of the graph. Okay, so on the negative axis.
I wrote like this graphic for the first 0. Like this is like the square root function. So I have like round 0 bracket and 0, and then I want to have negative infinity and 0 and square bracket.
I put square bracket for the first one.
Okay.
So I'm going to do another example with you guys. So let's do f of x is equal to x squared. Okay, so we're going to do both of the cases. So as x approaches positive infinity, so as x approaches like the positive x values to the right, y approaches what? 0? No.
Infinity.
Positive infinity.
Right. Yeah.
So as x approaches negative infinity,
X, I keep forgetting.
Yeah.
so as x approaches negative infinity, what does y approach? So if x keeps going to the left, what does y approach?
We're positive. We didn't do quadrant two.
Because we're talking about the y's, right?
Oh,
I'm still thinking about it.
right. That makes sense. There's got to be the quadrants.
So basically, you're seeing just where the line goes.
So you know the arrows of the graphs? You're just looking at those and where they're pointing. Okay. So in this case, these arrows are pointing upwards. So regardless if it's x is approaching positive infinity or negative infinity, the y values are going to be approaching positive infinity because they keep going up. Okay. The reason why this had a value is because of the asymptote. Okay.
Right.
So I'll do one more example.
What? Yeah, two circles. Thank you.
Okay, so for this new example, okay, just take a note of where the asymptote is, okay? So as x approaches positive infinity in the red graph, y approaches what? 3.
Sorry, I was unsure.
Okay, because it's never going to pass the asymptote.
It just approaches it. Yeah.
There's also one on the y axis.
I just put it here. I just made this random graph up. There's no real equation. So we're just looking at. I'm just doing it for your guys' sake, and just to give you an idea of how these two are similar. Okay. So as x approaches negative infinity on this side of the graph, the y approaches what value?
Three is
It's 3.
It's 3, yeah.
So it keeps going left, left, left. It almost hits 3, but it never actually touches 3. Okay, but it approaches it. So you guys are just looking at the arrows of the graph and where they're pointing. Okay, so that would be it for end behaviors.
So what's some statement over there?
Okay, so this is gonna help you guys for the even odd stuff, but we're gonna do this first. So using the parent function, so what you guys have from the first page of the note, what parent function has a range of YER such that y is greater than or equal to 0?
X squared.
Parabola. Okay, so we have f of x is equal to x squared. What else?
The square root.
Square root.
absolute value.
Yep. Is that it, or is there anything else? That should be it. So, yeah. So those are the 3 functions that have YER such that y is greater than or equal to 0. Okay. Why can't the let's just see. Why can't the exponential one be y greater than or equal to 0? Yeah, because it can't hit 0.
Yeah.
So we want to find the parent functions with a domain of XER. Bravo again. Good.
Linear.
F of x is equal to x. What else?
Exponential.
Exponential. Anything else?
Sinusoidal.
Sine x. All right. Is there? I think there's one more that we mentioned in the first one.
Absolute value.
Absolute value.
Wait, why can't the square root one be?
Because you can't have a negative square root,
Okay.
right? Because a negative square root just gives you an error. Okay. So for C, we want to find parent functions that have a infinite number of zeros. I think there's only one of that.
Of sinusoidal.
Yep. So f of x equal to sine x. And then the last one, we want parent functions that we have as x approaches negative infinity, y approaches 0. Reciprocal. And there's one more. It's in question B.
Absolute.
Nope.
Exponential.
Exponential. So remember, exponential has the asymptote at 0. So as x approaches negative infinity, it almost hits 0, but it never actually touches it. So it just approaches it. Okay?
Wait, so would D be a decrease interval or an increase interval?
It would depend on the graph. So
Like we won't know like,
until you actually graph it.
Like I didn't get like how did you know it's the reciprocal and the exponential?
Because if we draw it out, so this is the reciprocal, right? So as x approaches the negative infinity values, y approaches 0. Okay?
Oh, okay.
Remember, the interval of increase and decrease are usually in set notation. Okay? And behaviors are usually represented by this statement. Okay, so don't get the two confused. All right? Okay, so we wanted to, so this is where the even function, odd function is going to come into play. So remember, we know that even is f of negative x is equal to f of x. And we know odd, we have to prove that f of negative x is equal to negative f of x. Just gonna move this page down for a moment. All right, so which one do you guys want to try to prove first? Even. Even? Okay. So we want to try to prove even. So we know our f of x is 4x to the 5 plus 3x cubed minus 1. Okay? So for even, so f of negative x is equal to f of x. So 4 bracket negative x to the 5 plus 3. So wherever you see an x, you're just subbing it in with a negative x. Okay? Okay, so when we have a odd exponent and a negative number, what value does it give us back? Positive or negative? So when we have a odd exponent, okay, and we put a negative number to that odd exponent, does it give us a negative or positive value? Negative, right? So you have negative 4x5 minus 3x3 minus 1 is equal to f of x. Is the left side the same thing as the original function above? No. Okay? So therefore, not even. Okay? But because we proved that it's not even, we need to still check if it's not odd. Okay, so we have to do the second one. We have to do the second one as verification. Okay?
Yes, sir.
Yeah.
You said there was like a way of telling beforehand whether or not like leaning towards odd or to do even.
Yeah. It would be the exponent. Okay. I know. It's odd. Okay. So if we prove it's not even, then that's one less step in doing it. But we could start with odd. It doesn't matter. Okay. You can start with odd and even. But the reason why I started with even is because, as you can see, the odd one already has f of negative x. So if I prove that this is not even, then I can just use this or over here and not have to do the work again, right? Because this is already f of negative x. So for odd, we want to prove f of negative x is equal to negative f of x. So we know f of negative x is already negative 4x5 minus 3x3 minus 1, okay? But now we want to prove that f of negative x is equal to f of x multiplied by a negative, okay? So negative times, and we have our parent function, or a original function, 4x5 plus 3x3 minus 1, okay? Who can tell me what that simplifies to once I distribute the negative into the bracket? Yeah, Joseph?
Okay, so to negative 4x5 minus 3x3 plus 1.
Is the left side equal to the right side? No.
Oh, so it's neither.
So it's neither.
So wait, so that's why you got to prove it just in case it's neither?
So therefore, f of x is equal to 4x5 plus 3x3 minus 1 is neither, okay? The next lesson is easier. It's just transformation. So, yes.
So, sir, it doesn't matter, like, say for example, you have one odd exponent and one even exponent. It doesn't necessarily matter about that. It just matters about if there was an odd. That dictates if it's an odd function.
Yep. But in this case, because it had two odds, you could assume it's an odd function, but once you do the math, it's technically not an odd function because this graph is not rotated a certain way for it to be a function of odd symmetry. Okay. So this one would probably have 4 turning points. It'll be a graph that has at least 4 turning points with a certain amount of x's in it. So we're gonna do B. So B, we have f of x is equal to negative, f of x equal to the absolute value of 2x. Okay? So let's start with the even function. So we have f of negative x is equal to f of x. So all we're going to do is we're going to sub in a negative x for x. Okay? So we have square absolute value of 2 times negative x is equal to f of x. But what does the absolute value always give us back? Positive. Okay? So we're going to get 2x. So is it an even function?
Yeah.
Because it gives us back always a positive number, even if the x value is negative. Sorry, I should not have put that.
Wait, can we do an example for the reciprocal one?
The reciprocal one, so, So you want f of x is equal to 1 over x?
Yeah.
Okay. So let's try to prove it's even. So we have f of negative x is equal to f of x. Just right off the bat, do you guys think it's even going to be even? No, right? Why? Because you have 1 over negative x is equal to 1 over x, and that is not true, right? So therefore, this is not even. So let's try to prove that it's odd, okay? So for odd, we have f of negative x is equal to negative f of x. So we have 1 over negative x already is equal to negative 1 over x. So is it odd?
Yeah.
Yes. Because this is the same thing as writing therefore it is odd. Right? So we proved that it wasn't even, and therefore we need to prove it was odd or not odd. Okay? And based off the definition of odd and even symmetry, we were able to determine that 1 over x is an odd function. Okay. Right? I forgot how long this one lesson is. Well, lesson 3 is the bulk of it. Lesson 4 is like 2 pages long. That's it. So we want to identify the intervals of increase and decrease, the symmetry and the domain and range of each function. So these are questions that will probably take you a decent amount of time on like a test. Not because they're hard, but because they're, I would say, tedious questions, right? Because you have to do 5 different things. But we're going to take these on. So the first one we have f of x is equal to 2x plus 1. Okay, where is our y-intercept on this?
Plus 1.
Positive 1. And our x-intercept is at negative 1/2. So we will be drawing this over here. So let's start with the easy stuff first. The domain and the range. So what would our domain be for 2x plus 1? CR? Yes.
How did you get the negative one?
Oh, so x-intercept, you just have to move the set f of x equal to 0. And then you're just moving the 2x over or the 1 over.
Oh, right, okay.
Again, negative 1 over 2.
So you, like, you basically just did this quick, but like,
Yeah,
like,
just for you guys to know, so x-intercept, so we have set f of x equal to 0, okay? So you have 0 is equal to 2x plus 1. What do we want to move over to isolate for x? The 1, so it becomes negative 1. Yep. So that would be your x-intercept.
so it's like, you just rounded to 1, but like,
No, I put, this is 1 over, negative 1 over 2.
oh,
I just didn't scale my axis, so.
okay.
So let's just say this was 1 over here, and this is 2. So in the middle would be negative 1 over 2.
Okay, 'cause I was just confused, I was like, what?
Yeah, no worries. So that's how you guys find the x-intercept, okay? Just set f of x equal to 0, isolate for x, and then move the constant over, and then just divide by whatever is attached to x. So what would our range be for YR? All right. And let's go to the intervals of increase and decrease. So if we're reading it from from left to right, is there an interval of increase, decrease, or both?
Increase.
Okay. So where's my interval of increase from?
Infinity to infinity.
Well, what's on this side?
Oh, like negative infinity,
Yep.
and then like whatever positive infinity.
Yep.
Comma.
So our interval of increase is the only thing we have. It's from negative infinity to positive infinity. Okay. Is there an interval of decrease? Nope. So there's no interval of decrease.
We have to like state it. We have to like mention that.
Uh,
Are you just doing that for us to know?
I'm just doing it for you guys to know. On the test, if there's no interval of decrease, I will obviously not expect you guys to put it because I'll see it myself.
Okay.
But if there's both, then obviously include both. Okay. So now we have to figure out if it's odd or even, the symmetry. So just by looking at a line graph, is there any type of symmetry whatsoever?
Yeah.
No, there shouldn't. Really shouldn't be. So we just have to prove it. Okay. So we have, remember, even
Oh.
f of negative x is equal to f of x.
Well, yeah.
If it's neither, then yeah.
But just in case you should.
So because this is linear, it's actually pretty easy to do. Okay, so let's look at the even. So remember, for even, we're just subbing in negative x for x. Okay, so we have f of negative x is equal to f of x. So we have 2 times negative x plus 1 is equal to f of x. Negative 2x plus 1 is equal to f of x. Is that true or not true? Not true. So negative 2x plus 1 cannot equal 2x plus 1. So not even. Okay? And then for odd, since you already did the work for even, that's one less thing for us to worry about. So we're going to have 2x plus 1 is equal to negative 2x plus 1. Are those going to be equal to each other? No. Because on the right side, you're going to have negative 2x minus 1. So therefore, this is not odd, which means that there is no symmetry. Okay?
about it, like there was something part, like why is the one bracket,
The one?
in the odd part?
Oh, because you're multiplying the whole function by a negative. Because you have negative f of x.
When it's like one?
Yeah, because it's just negative. So it's just f of negative x. You're just focusing on the x part.
Okay, so why is that different?
So the reason why it's different is because you're only applying that negative to the x value of f of x, while the last one, negative f of x, you're applying that negative to the whole function. Okay?
Okay, got it.
That's
This is
F
outside of
negative
the
x is, F negative x is like constant.
Any questions?
F negative x is like constant as well.
Yep. Oh, let's see if I can even finish this before the break. Holy smokes. This lesson, brutal. It's not brutal in the sense of content, it's just super long. That's the only bad thing about this one. So the next one we have is f of x is equal to 3 to the negative x minus 1. Okay? So what does the negative x entail? It's reflected in what axis?
Okay, one.
So this is reflected in y-axis. Do we have an asymptote somewhere? Where is it?
Negative one.
Negative 1. So normally exponential would go from left to right, increasing, but because it's reflected in the y-axis, which way is it going to go?
Right to left.
Right to left, decreasing, right? And it's not going to be hitting 1. So we'll start with the easy part. We'll start with the domain and the range. So what would our domain be for this graph?
XDR.
XCR. And what is our range?
Y here, so that Y is greater than, negative one.
Correct. So in this graph, do we have an interval of increase or an interval of decrease? Decrease, okay. Then what is our interval of decrease?
The open bracket lead to comma,
Mhm.
negative one open bracket.
No, we're to remember the interval of decrease, the intervals of decrease and increase is just about the domain, not the actual y value. So it keeps decreasing from negative infinity all the way to positive infinity,
Okay.
right?
Right.
So wait, didn't we say didn't we say something about the zero, cause like, it was close to zero?
Or you mean what?
Oh, that's the end behaviors,
Oh, okay.
right? So if the end behavior for this one would be as y approaches
Oh,
positive
that's
infinity,
okay.
as x approaches positive infinity, y approaches negative 1. That would be the end behavior.
Or is interval of decrease or increase only for the
Only
domain?
for the domain. So remember interval, so interval of increase and decrease, you focus on the domain.
Wait, so it would be negative one if it stopped at negative one on the x-axis?
Pardon?
It would be like the second coordinate would be negative one if it stopped at negative one.
Yeah. So, so if this was a 0, or this was a close circle, and let's just say the x value here was 4, then it would be from negative infinity up until 4.
Oh, okay.
Okay? Because that's where the graph ends. So remember, intervals of increase and decrease, you focus on the domain. The end behaviors, you focus on the range of the graph.
Because my And behavior,
So just for you guys to remember, cohort A and C. So for intervals of increase and decrease, you focus on the domain. And for the n behaviors, you focus on the range or the y values. Times it. Okay, you guys can go for your, or like chill for like 10 minutes. It's already 9:40.
Yay.
Okay, cohort A and C, you guys can come back at 9:50.